Today we are going to study field programmable gate arrays architecture in detail. In 1985, a company called Xilinx introduced a completely new idea. The concept was to combine the user control and time to market of PLD with the densities and cost benefits of gate arrays. A lot of customers liked it and the FPGA was born. An FPGA is a regular structure of logic cells or modules and interconnect which is under the designer's complete control. This means user can design, program and make changes to his circuit whenever he wants. And with FPGAs now exceeding the 10 million gate limit, Xilinx Vertex is the current record holder. The designer can dream big. FPGA technologies. SRAM-based FPGA fabrics manufactured by Xilinx, Altera. Antifuse-based FPGA fabrics manufactured by Actel. Flash-based FPGAs by Actel. FPGA principles. A field programmable gate array is an integrated circuit that can be configured by the user to emulate any digital circuit as long as there are enough resources. An FPGA can be seen as an array of configurable logic blocks connected through programmable interconnects. These are the FPGA families: Atmel, Actel, Xilinx, Altera. This is a simple block diagram of Xilinx FPGA. Here, these are the configurable logic blocks. These are the I/O blocks and block RAMs. This is the block diagram of configurable logic block. FPGA can have lots of CLBs. The CLB's most important programmable element are logic function generators F, G and H. Both F and G can perform any combinational logic function of their 4 inputs, and H can perform any combinational logic function of its 3 inputs. Two 4-input function generators F and G offer unrestricted versatility. Most combinational logic functions need 4 or fewer inputs. However, a third function generator H is provided. The H function generator has 3 inputs. 0, 1, 2 of these inputs can be the outputs from F and G and the other inputs from the other CLBs. The CLB can therefore implement certain functions of up to 9 variables like parity check, expandable identity, comparison of 2 sets of 4 inputs. With appropriate programming of multiplexers, the output of function generators can be directed to CLB outputs X and Y, or they can be captured in age-triggered D flip-flops F1 and F2. There is a clock-enabled signal. The sources of EC and 3 other internal signals are selected from a set of 4 miscellaneous inputs C1 to C4 by multiplexers at the top of the CLB. input-output block, that is IOB. The IOB's other logic controls are selectable polarity using multiplexer for its 4 inputs that come from CLB array via programmable interconnect. Out, T, output clock, input clock, these are the inputs of IOB, whereas I1, I2, clock enable, these are the output of input-output block of FPGA. Other blocks that you can see, there are flip-flops, multiplexers, slew rate control, input buffer, output buffer, and passive pull-up network. Programmable interconnect. The number in each arrow indicate the number of wires in that signal path. The 4 wires in group labeled global clock are optimized for use as clock inputs to the CLBs, providing short delay and minimal skew. The 2 signal groups are optimized for flexible connectivity between adjacent blocks without small numbers and unidirectional limitation of wires in direct connect group. Wires in double groups travel past 2 CLBs before hitting a switch, so they provide shorter delays for longer connection. For really long connection, the long groups don't go through any programmable switches at all. They travel all the way across or down a row on column and are driven by 3-state drivers near CLB. It is possible to connect a CLB to another that's more than 1 hop away using single wire, but they have to go through a programmable switch for each hop, which adds delay in it. These are the differences in CPLD and FPGA architecture. CPLD provide high performance, but they also contain fewer registers than FPGAs. FPGAs are offered in a wide density range, from a few thousand gates to several million gates. CPLDs are ideal for complex blocks with large number of inputs. FPGA architecture is more granular compared to CPLD architecture, making it suitable for designs with large number of simple blocks with few number of inputs. A number of input-output pins offered on the CPLD were significantly higher. A number of input-output pins offered on FPGA were significantly less than CPLD. Space required is less board layout complexity, and less cost than FPGA. Space required is more cost than CPLD, but less complex. CPLD does not require any memory stores configuration program. FPGA require memory to store configuration program. CPLD consumes more power than FPGA. FPGA consumes less power than CPLD. Thank you.